Hey, my name is Dario Tranchitella, and I am the co-founder of Classics, the company that open sourced Kamaji, which is the hosted control plane for Kubernetes. If you have to run dozen or hundreds or thousands of Kubernetes clusters, the control plane tax is something that will eat you soon because you need to allocate at least 3 virtual machines for the control plane. With Kamaji instead, we translated the design of the hyperscalers where the control plane is running in a management cluster in a dedicated infrastructure, so the control plane can't be hijacked by the customer and you are getting a sort of managed Kubernetes service. In this demo, we are going to show you how you can use Kamaji with Talos. So essentially, Talos is considered the best Linux distribution for Kubernetes by the community. And the reason is that it's immutable and it's also API driven and purposely built to run Kubernetes securely and reliably with zero manual intervention. I already discussed about Kamaji, but before proceeding, I want to show you the GitHub repository I'm talking about. So if you're not familiar with Talos, essentially it's immutable. It supports a variety of environments. You can run Talos on VMs, you can run Talos on the edge devices, or even on bare metal, which is one of the most interesting use cases because with virtual machines you have APIs, but for the bare metal, it's slightly different. It's very hard. And how can you apply these APIs? Essentially, Talos provides a command line interface, so Talos CTL, and the design is pretty neat because as developers, we are pretty used to interact with the APIs, but for the OS, it doesn't exist at all. So with Talos CTL, you can configure the endpoints and you can manage nodes. So you can apply a configuration, you can rotate certificates, you can join worker nodes, you can run Kubernetes, etcd, etc., etc., etc. So Talos has been designed to run especially Kubernetes workloads and Kubernetes clusters. And with Talos, you can create the control plane and then the worker nodes. The control plane must be Talos based, and it doesn't perfectly match and fit with this Kamaji instead, because with Kamaji, we are leveraging on the concept of hosted control plane. So it means that if we take a look to the architecture here, we have a management cluster, which is based on virtual machines or bare metal instances, doesn't matter, but the control plane is not running like a virtual machine. And in Talos, the worker nodes, they're expecting to contact an instance which is Talos based. Here instead, what we do with Kamaji is that we are running control plane as pods, which provides several benefits. The first one is related to resources because you can decouple the data store like etcd from the stateless components like the API server, the control manager, and the scheduler, so you can bin pack more the control planes, and furthermore, also for the operations is slightly easier because Kamaji is an operator and it matches the expected state with the current status in the cluster. So you can forget about getting paged in the middle of night. What's really important is that with Kamaji, essentially, you're achieving the same nature of the managed Kubernetes services because the control plane is segregated in a different infrastructure and you can't hijack that, and you just need to bring your own kubelets. We support cluster API, but everything here is based on kubeadm, so it's a vanilla Kubernetes distribution. But of course, we got the problem that now has been sorted out because the worker nodes, if they are Talos workers, they're expecting here to get a Talos control plane. And to overcome that design, we implemented a transparent layer, which has been called Talos CSR Signer. And what's the problem between inverted commas is that we have two PKIs. We have the Kubernetes one, which is created by kubeadm and eventually by Kamaji itself. And then we have the Talos machine PKI. And of course, we need to get this problem sorted out. And what we did is that we are always leveraging the concept of hosted control planes, but we are using a sidecar. And the sidecar is listening on this specific port, which is the Talos 1, and the Talos worker just need to interact with this port to get the certificate, sign, and then all the kubelet communications will happen as usual. And this is the flow. So the Talos worker generates a CSR, sends with the gRPC along with the metadata to the signer, and the signer, which replicates the same flow expected by Talos worker nodes, respond with the CA and the certificate, and finally the worker nodes that can join the Kubernetes cluster. For our demo, we are going to follow the sidecar deployment guide in the repository. We already built also the container images, so they are for free. This open source, this project is licensed under Apache 2 license, so it's open source. We are waiting for your feedback and your implementation. And to avoid any mistake, I created this simple bash where we are following all the steps. So the first one is that we need to source the environment variables. So your mileage may vary. So we have the worker IPs, Talos version, the control plane endpoint. So I got mine. And what I need to do, the first thing is that I need to generate the Talos secrets. So Talos CTL will generate my CA, some configuration files, and this CA must be stored in the management cluster because the CSR must mount that to sign the certificates. So in this step, I'm going to create a sample, which is the name of my cluster, Talos CA secret. And I'm going also to integrate with Cert Manager. So in Kamaji, we are using Cert Manager to handle a lot of tasks. And essentially, I just want to avoid creating OpenSSL and add further manual steps. And now what we need to do is deploy the control plane with Kamaji. So with Kamaji, we have a manifest you can apply. And essentially what Kamaji is doing is that it's creating the CA, the API server certificate. It's configuring itself to expose the API server on a load balancer. A lot of manual tasks here, but the benefit is that we are running as pods, so we are quicker. We can use Kubernetes to re-implement the reconcile loop, and as you can see here, in the end, in less than a minute, we have the control plane that's ready to handle a request. Now it's matter to focus. It's time to focus on our worker nodes. So I'm going to start the bootstrap process of the worker nodes. Keep in mind that I already created with my script in another environment my virtual machines with Talos, and I need to create the Talos configuration and create worker configuration. And now it's a matter of joining the worker nodes. So as I said before, we are following these steps, and I'm going to use the Talos CTL apply configuration. So you can use Cloud Init, you can use whatever you want, doesn't matter. Just for the sake of simplicity, I'm using Talos CTL. And I'm going to do that for my 2 worker nodes. So as you can see here, our gRPC server handle the request because we have these 2 nodes, 100 and 101, that require to get a certificate. So it means that Talos get the certificate from our CSR Signer, and now the kubelet is running and is joining the cluster. So I can verify the worker nodes. So take a look here, kubectl with the kubeconfig generated by Kamaji, get nodes. And what I'm expecting here is just the worker nodes, which is like any Kubernetes managed service experience. So you don't see the control plane. You can't hijack the control plane. You just need to bring your own nodes. And the benefit is that here you can focus just on Kubernetes itself, as well also with the worker nodes with an immutable and also API-driven approach. But of course here, as you can see, the nodes, they are not ready because we are missing the CNI, and I'm going to install a sample CNI. With Talos, you have plenty of options available. Just for the sake of simplicity, we are using here Flanel. And what I'm going to do is to wait for the conditions. So the demo set has been deployed, we got the pods, and we need to verify the cluster. For the sake of simplicity here, we are going to check if the pods are running, and you can get through all the steps here. So we are going to get the nodes, the pods, the logs, and then we are going to verify the worker nodes. So we are checking the nodes. Everything is ready, as well also as the pods. And please take a look here. We don't have the API server, the control manager, and the scheduler, or even a CD, because that's managed by Kamaji. With this integration, you can take the biggest advantage of Talos, which is the API driven with Talos CTL, and combine that with Kamaji. With the add-on, essentially, we implemented the minimum bear set for the CSR, for the certificate. So it means that you can always still use Talos CTL, which is the official way of handling the instances. But the benefit here is that we are able to work together with Talos along with Kamaji without stepping each other's toes, which is the best thing. And now what we can do is just verify that the Talos worker is working expected on all the workers. And you see here that we are not mangling the configuration. We are always using the Sidero Labs official images. And with that said, our demo has been concluded. I hope that we can get your feedback to give a try to Talos and with Kamaji. And I'm looking forward to your feedback. It was a pleasure. Cheers.